I'm like, I always walk around. I think this time I'm just gonna like rise from down below. So I just want to keep you on your toes a little bit there. Let's go get some special right triangles, specifically the 30, 60, 90. Let's go. Let's go. This is why it's so damn special, is because that shape is so damn beautiful. That's an equilateral triangle. It's the perfect division of 3. Each point is the same distance from the other 2 points. That point is no closer to that point than it is to that point. It's a beautiful thing, the equilateral triangle. And what happens when you draw an altitude from the equilateral triangle is you get that to be 5 and that to be 5. Because all the sides are the same for this gorgeous triangle, so are the angles. They're all 60. And so when you cut it in half, you get 30 and 30. And this sets up the 30, 60, 90 special right triangle. So I'll draw it here. Boom, boom, boom. So this is 60. That's 90. All the angles of a triangle always add up to 180. Every single time on every single planet. That means this one up here must be 30. Now, if we're 10, then this is 5, we know that. The question is going to be, what's this height? Now, right triangles have 3 sides, of course, because it's a triangle, but they got special names, and here's what they are. The sides that make up the 90-degree angle, those sides, we call them legs. So we got a leg here, we got a leg there. The side across from the 90-degree angle is called the hypotenuse. So it's going to be important for us. I keep looking for this blue pin. Oh, there it is, right there. It's going to be important for us to try to figure out, initially when we look at this shape, to identify the hypotenuse. This is going to be called the short leg, and this is the long leg. Now the short leg is always going to be opposite the smallest angle. Smallest angle, smallest leg. So it's opposite the 30, the long leg's opposite the 60, and the hypotenuse is opposite the 90. Okay, so look at this thing with me, right? Just look at this thing. Here to here is a times 2. That's the relationship because we know, so that's the relationship of the short leg to the hypotenuse. Because the short leg is half the hypotenuse. If you reflect this triangle over, you can see that more directly, because that's also 60 down. So I'm going to just write that right here. So this is something to remember, is that the ratio of the hypotenuse to the short leg is always a 2 to 1. Because every single 30, 60, 90 right triangle, they all similar. They all similar. And so the ratios of those sides are always going to be the same. Meaning, if one 30, 60, 90 right triangle is a times 2, then they're all going to be a times 2. Yes, sir. But now we got to figure out what's the ratio here. What's the ratio of the long leg to the short leg? Well, if you do a little Pythagorean theorem here, you get 5 squared plus x squared is equal to 10 squared. So I'll skip a few steps. Boom, boom. So x is equal to the square root of 75, which is the square root of 25 times the square root of 3, which is 5 root 3. So I did that really fast because it's not really the premise of what I'm trying to show here. So this distance here is going to be 5 root 3. And so it turns out that this is a times root 3 sort of thing. And so the ratio of the long leg to the short leg is root 3 over 1. Those are the only tools we need to make this happen. All this jazz down here, this can help you if you forget root 3. If you forget the root 3, this jazz here, you set this up, this will help you. So let's look at what some of the other problems are gonna be. So there we're started. Now let's look at something that you might be looking at your homework assignment or something like that. You might be looking at a 30, 60, 90, and they may have just given you, say, this side to be 7. So what are we going to do now? And I ain't going to ask you to pause. I'm just going to assume you paused it. Let's roll. The biggest mistake you see is students, they know there's this times 2 relationship and they know there's this root 3 relationship, but they can't quite figure out which side the relationship is. So the remedy for this is to first identify where the hypotenuse is. Hypotenuse is opposite that 90-degree angle. If you draw a little arrow that goes from one corner of that box to the other, it points to the hypotenuse. Now go and identify the short leg and the long leg, remembering that the short leg is always across from the smallest angle. And you've got options now. Here's option number 1 is you remember that this is just a times 2. And so if that's 7, then this up here must be 14. You can't just remember that. You could also come on this side and remember that, well, this is a times root 3. And so if this is 7, this must be 7 root 3. And then you're done. Holla! Now, but let's say maybe you didn't remember that. Here's some other ways you could go about doing it. Mr. Miller, thank you for showing us more than one way. Oh, man, you don't have to thank me. You don't have to thank me. Oh, hell no, you don't got to thank me. It's my job. It's what I do. It's what I do. Okay. So here's another way of getting this exact same thing. You say to yourself, and a lot of students really like this because it's more like a formula. You say the ratio of the height of the short leg is 2 to 1, which is equal to x over 7. So assuming I just called this x, like I was trying to solve for that. Then cross multiply. So 1x is equal to 14. So x is equal to 14. To down. How do you like me now? All right. You could do that over here as well. Remembering, right, this is the long leg and the short leg. And you could say the ratio of the long leg to the short leg. Well, I'm going to give myself a little bit more room than that. You could say the ratio of the long leg to the short leg is equal to root 3 over 1. Now, you didn't know the long leg, so let's call that, say, y. You know, the short leg is 7. You have a proportion here because you got equal ratios. So that gets you y is equal to 7 times root 3. And that is simplified enough. So you've got a couple options, right? You got a couple options. Another thing you can do is you can reflect this triangle over. And that usually will help students realize that this is 14 because they see that that's 14 and they know that they've created an equilateral triangle. Well, hallelujah. Let's do one more. One more. Now I'm going to want you to try this one on your own. You know that, right? I got to I'm going to maybe change the orientation of it just a bit here. So I'm calling this is now the 60. Okay, so this one over here is the 30. I'm going to give you this side as, say, I'll give you this side as 10. And you got to solve for x and y. So you're going to hit pause here. I'll even smile for you while you hit pause. So are you ready? So you're going to try when you hit pause. Ready? Pause. Unpause. Oh, jeez. What the hell? They don't make pens like they used to. All right. Mr. Miller, please do not smile like that ever again. That gives me nightmares, man. What the hell? Sorry about that. All right. So now what are we going to do, right? We got some options. First, I'm going to make sure I identify the hypotenuse. Now, the long leg is always across from the largest angle, which means this is the short leg. So let's look at option number 1 is pure, go back to the formula. We could say the ratio of the hypotenuse to the short leg is 2 over 1. And we know the hypotenuse is 10. We don't know what the short leg is. That sets up a proportion. Remember, the reason we cross multiply is if you write any ratios that you know are the same, like those two ratios are the same, you might notice that if you multiply the top by this bottom, that it's the same as multiplying this bottom by that top. And that's true every single time. So in math, we take advantage of that, and we say that that is 10 times 1 is 10, And so x is equal to 5. That's one way to get it. So now we have that this is in fact 5. And we remember that is our times 2 relationship. So once we have the 5, if you can remember that it's a times root 3 ratio of long leg to short leg, then the answer over here is going to have to be 5 root 3. If you don't recall that, you might go back to your equations and say to yourself, well, the ratio of the long leg to the short leg is always going to be root 3 over 1. In this case, I know the short leg is 5, but I don't know the long leg, right? That was my y, so it'd be y over 5, and that's a y. And now you cross multiply, and y is equal to 5 times root 3. Holla for $2. All right, so we're good here. Trying to think if there's any other ways we could have gone about this particularly beautiful problem. I think this is potentially a way. If you remember that if we're a times 2, when we're going short leg to hypotenuse, right, because that's the 30, well, by definition, we must be going times 1/2 the other direction, because it's the inverse. I mean, if you rewrote this, you could do short leg over hypotenuse is 1 over 2. That's the ratio of this leg to that leg. And so you could go 10 times 1/2 is 5, and then you know this is a root 3, so you get 5 root 3 on that end. Maybe I'm crazy. I don't know. Maybe I'm crazy. I'm going to pause it there. Remember, I am a buffalo, and I do what I want. That's what my sticker says. That's what my sticker says. I need a drink of water here. The more complication of this is when you're given this side first, but maybe that'll just be the next video. Maybe it'll just be the next video. I appreciate your time and your energy. Remember that angels fly because they take themselves lightly, all right? Okay, take care.